So today's topic is pharmaceutical application of purification. Membrane filter and artificial membranes are used as model to explain the principle of diffusion of drug through the natural membranes. Second is drug protein binding event can be studied. And next is properties of colloids. Properties of colloids are three: optical, kinetic, and electrical. So first we study about optical properties. Optical properties means interaction to lights. It is useful to measure the size, shape, structure, and molecular weight of colloids, include light scattering and turbidity. Then we see a diagram. In this diagram, when a beam of light strikes a particle, it polarizes the light and induces the dipoles in these molecules. And these dipoles emit weaker light at the same wavelength as that of the incident light. This emitted light propagates in all the directions. This phenomenon is called light scattering. Larger particles scatter more light. In this diagram, we see a light passes through a pure, simple dispersion medium and pass without a deviation. When the light is passed through the collision dispersion, light scatter. Now we study Tyndall effect. Tyndall effect is observed when the interactions of particles with the light. When the intense or narrow beam of light is passed through the dispersion medium, collision dispersion medium, its path is visible due to the scattered light. This scattered beam is called Tyndall beam, and it is studied in light ultra electron microscope. In light microscope, source of radiation is visible light. Two separate particles are visible if the difference between them is 0.2 micrometer and not suitable for colloidal particles. Second is ultramicroscope, also called as a dark field microscope, is used to observe Tyndall effect when the dispersed particle appears as a dark spot in the dark background and is used to determine the zeta potential. And third is electron microscope, is used to measure the particle size, shape, and structure. Radiation sources high energy electrons, and wavelength decreases, resolution increases. It also gives the photographs of the actual particles. Turbidity. This method is used to estimate the concentration of the dispersed particle and molecular weight of the solute. Equipment used are spectrophotometer and nephelometer. In this spectrophotometer, it measures the intensity of transmit light in the direction of incident light. And then, if the amount of dispersed solid is high, more light is scattered and transmit light will be less intensity. This is a relationship between the turbidity and light intensity. Lyophobic colloids gives the high turbidity because of high scattering and low transmission, and lyophilic colloids give low turbidity because low scattering and high transmission. Next is nephelometer. Nephelometer, when the amount of dispersed particle is low, the intensity of scattered light is measured at the right angle to the direction of the incident light. I repeat, when the amount of dispersed particle is low, intensity of the scattered light is measured at the right angle, that is 90 angle, only applicable to lyophilic colloids. And then is light scattering turbidity. This method is used to study the protein, polymers, association colloids, and lyophilic salts. It also used to measure the molecular weights of polymers. Principle is light source having the wavelength higher than the dimension of the particle is used here, and then the turbidity is measured from the scattered light at the particular angle. Spherical missiles. If the particles are spherical, the light will be same in all the directions. If the particles are rod-shaped or laminar, then then it gives different effect along with the right angle or to the direction of the flow. Next is kinetic property is used to detect the stability of system and molecular weight of particle. Transport kinetics includes Brownian motion, diffusion, sedimentation, viscosity, colligative properties. Brownian motion. Brownian motion is named after the Robert Brown who proposed this theory. It said that colloidal particles do not sediment because of their small size. In other words, particles are continuously random motion. Thermal energy keep particle in motion. Due to motion, they collide with walls and other particles change their direction and velocity. Some particles move against the gravitational force. Fourth point is Brownian motion stop with the increase in size and viscosity. It can be viewed by light microscope. Diffusion. Diffusion is colloidal particle of small size passes through the porous plug, and diffusion is a direct result of Brownian motion. Fick's first law states that particles diffuse spontaneously from the higher concentration to lower concentration until the equilibrium is maintained. This relationship is used to determine the molecular weight of the polymers. In diffusion experiment, quality of drug is diffused according to this, and next is Graham's law state that speed of diffusion is fast, it forms crystalloids. Speed of diffusion is slow, it forms colloidal substance. And then next is sedimentation. Sedimentation is this is influenced by the gravitational force applied only for a particle size greater than 0.5 micrometer. And if the particles have Brownian motion, there is no sedimentation. Application is molecular weight estimation and study micellar properties of drug. Colligative properties. Colligative properties only depend upon the concentration of solute or ions or molecules. And there are four colligative properties: boiling point, freezing point, vapor pressure, and osmotic. In this, only osmotic is used for the measurement of molecular weight of dispersed particles. Now, next is viscosity. There are many parameters that affect the viscosity. First is shape. If the particle is spherical in shape, then the lower the viscosity. If the linear shape, it is higher viscosity. Affinity of particle to medium. Lyophobic, which is linear shape, increase the viscosity. And then next is type of colloidal dispersion. Dispersion medium of lyophilic, increase viscosity. Lyophobic, decrease viscosity. Fourth is higher the molecular weight of polymers and higher the viscosity. The third is electric properties, surface charge, zeta potential, and electrophoresis. Surface charge. Dispersed particle have charge on surface, and the dispersed particle is added in an electrolyte solution, form electrical double layer. What is zeta potential? Zeta potential is a potential difference between the dispersion medium and the layer of fluid attached to the dispersed particle. Because there is a distribution of charge around the particles, and then they cause a potential difference between the layer and the solution across the diffuse layer. So this is called a zeta potential and is used to predicting the stability of colloidal dispersion. Electrophoresis is used to determine the size, magnitude of zeta potential and the movement of charged particles under the potential difference. So next is sign and magnitude. Particle move towards anode, collide negative charge. Particle move towards cathode, collide positive charge. Magnitude is rate of magnitude is directly proportional of the charge of the particles and the potential gradient. Ultramicroscope measure magnitude standardized by particle of known potential. So velocity of the particle migration is directly proportional to the potential gradient applied. Dome membrane equilibrium states that this principle is used to enhance the absorption of the drugs such as sodium salicate and potassium benzyl penicillin by using sodium CM, in which the sodium CMC is a ionic pro-electroic pro-electrolyte non-diffusible. So it not cause the semi-permeable membrane. And sodium CMC, when combined with ionic drug, it is diffusible and increase the concentration. Another example is non-ionic Another example is ion exchange reaction of sulfate and phosphate ions. In the initial stage, the solution of NaCl is placed on the one side and the another side is a negative and the charge collide. Volume of both sides should be considered as equal, but when soon after there is equilibrium is maintained, according to the condition of electronegativity, there should be a both sides of the membrane should be same. So outside is equal to Na positive O is equal to Cl negative O. Inside is sodium ion inside equals to chloride ion inside plus R ion R negative inside. By substituting this value to the equation number 1, we get this equation. And this equation states that these equations represent the donor membrane equilibrium and calculate the ratio of concentration of the diffusible ion outside and inside the membrane. Solubility or stability of the colloids are, if the colloidal dispersion is stable, then it means a Brownian motion. It is unstable, it means a precipitate. Reasons of lyophilic are solvent shield on particle and lyophobic electric charge on particle. Lyophobic colloidal stability, these are the 4 scientists which give this theory, and this theory is based on the difference between two particles and their interactions and exhibit the Brownian motion causing collisions. And third is amount of electrolyte control, stabilization and precipitate. So these are the interactions between the particles are van der Waals attractions, electrostatic repulsion curve, and third is net energy interaction.